Hello everyone, welcome back to my channel. Today we are going to solve one more problem from LeetCode, which is going to be an addition to our competitive programming series. So today we'll solve 26 number problem from LeetCode, remove duplicates from a sorted array. Here in the problem description, given an integer array nums sorted in non-decreasing order, remove the duplicates in place such that each unique element appears only once. The relative order of the elements should be kept same. So here we basically need to remove the duplicates from a sorted array. So I'll tell you what they have explained here through this example. So here in the example, if you see, you're given an input array with element 1, 1 and 2, and you simply need to return an integer value which will tell that this many unique elements are present in your array. So from this input array we can say there are two elements unique, 1 and 2, right? And in order to solve this problem, you need to modify this given input array in such a way that your one of the part of array will have all the unique elements and then the other part will remain as is. Okay, so to understand this better, I'll take you to a scratch file. So for example, let's say you are given this nums array. Okay, now you need to return a integer value, so your output will be here as 3 because you have three different unique elements, right? 0, 1 and 2, and your resultant array after modification should look something like this, where all your unique element will reside at the first half of the array, and then it doesn't matter what all other elements are there in the second part of the array. So here you simply need to make sure that your first part of the array is having all the unique elements and also the relative order of the elements are maintained. As we are given a sorted array, we will always have something sorted at the first part of the element. And finally, we should be returning the integer value, which basically tells you the number of unique element in the array, and based upon which your input array will be scanned to see all the unique elements. So if your output value is 3, that means it will just check for the first 3 elements of the array. Okay, so I hope the problem statement is clear. Now we'll see what are the different approaches to solve this problem. So first we'll start with a very naive approach where we can simply use a hash set to solve this problem. Let's see this approach. So here we'll be using a hash set, and let's say we are given this input array. So what we can simply do is we can simply iterate through this array and keep inserting each element in the set. So for example, let's say if you are initially your set is empty, you iterate through the first element, you insert 0 in a set, and next you see another 0, but as this is a set data structure, it won't allow any duplicate elements. So next we'll see 1, so it will try to insert it, it will get inserted in the set data structure, and then again it will get 1 which is already there in the set, so it will not get inserted, and then we have 1 again, so it won't get inserted, and then we have 2, so in set it will allow to insert 2, and then for another 2 it won't allow to insert. So finally, after traversing this array, we will have 3 elements in the set, and next we simply need to iterate over this set data structure. Also we know that this set will keep all the elements in the ascending order, so it is fine to iterate over this set data structure and just keep replacing each element. So let's say if I start with this element, I'll simply replace the first element with 0, then in the second element I'll simply replace it with 1, and for the third element I'll simply replace it with 2. So in this way we have just modified the first part of the array, which is having just the unique elements, and then we can simply return the size of the set, which will basically your expected output, and it has 3 elements at the first part as unique, and we can simply ignore the other part, right, as it was mentioned in the question. So what should be the time complexity for this approach? So as we are iterating over this array once, it requires order of n time complexity, and also we are doing some insertion operation on set data structure. So for that, in Java it is of constant time complexity, but for other languages like C++, where set uses red black tree implementation internally, so it will have log n time complexity. So for now I'll simply consider time complexity n log n. So one point I would like to highlight here is don't get confused with this log n, because you can simply explain it to your interviewer that if you are using some data structure which is using tree implementation internally, so it will have log n time complexity for insertion, and for Java, as I mentioned, that it will have constant time complexity. So you can also go for order of n time complexity. Okay, and for space complexity, so as we are using set data structure for storing these elements, so in the worst case, if you have all the elements as unique, then it will require order of n space complexity. So here we can see that using this approach, we will have time complexity as order of n log n and space complexity as order of n. Now we will see how we can optimize this complexity. So for that, we'll see approach 2. So here in this approach 2, we can simply use 2 pointers. So let's say you are given this input array. So here we will be using 2 pointers I and j. So initially your I will be pointing to the first element and j will be pointing to the second element. And then we'll simply compare if the value at I and j are similar or different. So for this one, the value at I and j are similar. So what we will do, we'll simply increment the j to the next value. And now we will compare if the value at I and j are same or different. So for this one, we have 0 and for j, we have 1. So these are different. So in this case, what we simply need to do is we simply need to increment the I by 1. After incrementing I, we simply need to assign the value at j to the value at I. So this 0 will become 1 and then we'll increment the j by 1. Again, we will do the same thing. We will simply compare the value at I and j. This time these values are same, so we'll simply increment j. Again, these values are same, so we'll increment j. And then once we see that the values are not same, what we do, increment the value of I with 1. And then what we need to do, we need to simply assign this value at j to the value at 1. So basically we are replacing the value of y with the value of j whenever we have different values at I and j. So now this will become 2 and your j will get incremented. And then again we compare the values at I and j, and now we see that these values are same, so we simply increment the j. But this time we see that j is crossing the size of the array, right? That means the iteration is over. So from here at this moment we can see that I is pointing at the third element and this part of array is having all the unique elements. And also as we know that arrays start with 0 index, so we can simply assign this index for now so that we can say what needs to be written. So if you see, indexes are 0, 1, 2 and our output should be I plus 1, right? So here our I is 2, so we can say 2 plus 1 equal to 3. Okay, so this is going to be our output. So with this we can say we have 3 different elements and we can say that this is going to be a modified array. So now we will see what would be the time complexity for this approach. So now as we can see that we have iterate over this array only once, that means it will require only order of n time complexity. So we can simply say that the time complexity is order of n, and also we haven't used any extra space, so we can simply say that space complexity would be constant. So I hope this approach is clear to you and you must have learned how you can use 2 pointers to solve this kind of problems. So now we'll see the Java solution for this problem. So here is the Java solution where we have this method remove duplicates with input parameter nums array. The first thing we do is we simply checks for if the length of the array is 0, then we simply return 0. Otherwise we use 2 pointers, one which points to the first element and the other pointer which points to the second element. And then we simply compares the value at these 2 pointers if they are same or not. If they are not same, we simply increment the I and then we simply assign the value at j to the nums of I, right? This is what we have seen in the slides, right? And once this iteration is over, we simply return the value I plus 1, which will be your unique number of elements. So yeah, that's the Java solution for this problem. So I hope the solution is clear as the code is quite simple. So that's it about this problem. I hope you have learned something new today. And if you're new to this channel, do check out my competitive programming playlist where I have added more such videos which will help you to enhance your problem solving skills. That's all about this video. If you learned something from this video, please hit the like button. And if you're new to this channel, please don't forget to hit the subscribe button and press that bell icon so that you get notified for our upcoming new videos. Thank you for watching.